Hello, dear students. Today, we are here to talk about atomic structure part 2. In part 1, our guest lecturer Nurul Haq had discussed about radial wave functions versus radius plot for different subshells of electronic cloud. Here, now he talks about radial probability versus radius and RDFs versus radius. Students, just visualize the probability of finding a matter wave with respect to origin nucleus. Let us see how our teacher, Mr. Hawk, explains further. Go ahead.
Dear students, as you know, we are still cultivating the concept of node, that is radial node and angular nodes. And in the first class, we have drawn radial wave function versus radius plot from the number of nodes, and same time I have also discussed the nature of radial wave function with respect to variable r. Now, rose the further, this part of video will discuss another plot, that is radial probability versus radius. You know, probability is the radial wave function square, and radial distribution function versus radius of different subcell. And that plot also comes from the counting of number of radial nodes. That you know the formula n minus L minus 1, that is the number of radial node. Now, you know, I am taking an example 2s. You know, here the number of radial node is formula, you know, n minus L minus 1. Put n is equal to 2, L is equal to 0, that is 1. There you will get 1 node. If I do plot radial wave function versus radius, that I have already discussed in my first class of this part of atomic structure, 2s, at the origin is maximum, there is a 1 node, this is the plot, radius versus radial wave function versus radius. Now, radial probability versus radius. Probability means square. You know, wave function square has a great physical significance. It will define the electron finding probability in a particular region. And when I will do plot radial probability of this 2s orbital, that is the R2s, R is capital R is the radial wave function. You know, a complete wave function you can express in terms of radial wave function as well as angular wave function. Square means this is radial probability. Remember, this radial wave function square, it will represent a radial probability. Probability idea you have from the mathematics. Since here we are considering electron as a cloud, and the electron finding probability in a particular region, here is the radial probability, not complete electron cloud. Now if I do square, square means an even function, it is plus its square, nature like same. I am drawing here qualitative plot. Also, you have to plot qualitative, not quantitative, remember here. And this minus also becomes plus when you will do square. That means this looks like this one. This minus part square, it becomes plus. Since it is an even function, this is the node. That means you got idea how you will draw radial probability versus radius. Now I take another example. Another example I am going to take 4p orbital or 4p subcell. Now number of radial node 4 minus 1 minus 1, that is 2 number of radial node. You know the formula. Radial node depends depends on N and L both. Now if I do plot it, a radial wave function R4P versus R, there are two nodes, and I told you, apart from S subcell, P, D and F, they are 0 at the origin. At infinite all are 0. And that 0 is not a node. Here are two number of nodes you have to draw. This is the radial, these two are the nodes that you know already. Now I do convert it into radial probability 4p square. How you will get? This is already plus, minus also will be the plus since it is a square even function, and the plot looks like this one. There are two nodes, these two are the nodes, all becomes plus. And remember that when you will draw radial probability versus radius, the amplitude, this amplitude decreases. Remember this one, this amplitude decreases. Here two number of nodes. By this way, you will able to draw the different orbital, that may be S or P, D, F. Do count the number of radial node and from their plot radial wave function versus radius and do square. Square means even function, that minus negative phase becomes positive. These are the plot of radial probability versus radius. This is radial wave function versus radius. I think these two examples are enough to draw the other orbitals. Try to do it. Radial distribution function. Radial distribution function. Distribution function. That is simply RDF. Now the question is, what is radial distribution function? That I am going to discuss with you. You know, psi is a wave function, a complete wave function of an electron, and which is the function of R, theta, phi. Someone can write in terms of quantum number psi n, l, ml. I told you n is the representative of radial coordinate, l and ml are the representative of angular coordinates. By any presentation technique you can use. Now it has no direct physical significance. It will just give idea about the amplitude of the matter wave, and matter wave, remember, is different from the electromagnetic wave. Now, square of this wave function, if I take this square of this wave function, it has a great significance. It will represent the probability density of electron. Now if I do integrate, if I take a small region, with respect, this is the nucleus, this is a small region. Tell me, what is the probability of finding of electron in this region? How you will do it? By using the mathematics. This is the probability. Let its value is d tau, or you can say dv simply. Let it is dv. And if I take Cartesian coordinate, you can say this is dx into dy into dz, and you can easily convert into polar coordinate. This is the small volume region. I want to mention you that what is the finding probability of electron in this small region. If I take it as a sphere, what is dv? You will get by doing simple calculus. You know v, if I take it as a sphere, that equals to 4/3 pi r cube. That is the volume of the sphere. volume of the sphere. By take this is origin, this is R. Now I will take small sheath. I am taking only the radial part, small sheath. Now my question is, what is the electron finding probability in this small thickness of the sphere? What I have marked here. Let it is R. It was R. I have increased to this distance is R plus, this is R plus dr. That means the thickness of this is dr. Dr I will take here tends to 0. Very, very small. More accurately you can measure. Otherwise it will come average. P 4/3 pi r cube. Now what is the volume of this region? Where I want to measure the electron finding probability, radial probability. That is dV, that is 4, just do differentiation, 3r square, 4 pi r square dr. You got the volume. I am taking one dimensional. But in 3-dimensional, if I take it is d tau, tau is the dx, dy, dz, all three coordinate, r, theta, phi if I do consider. This is complete wave function, not only radial. Now, if I do integrate minus infinity to plus infinity, can you tell me what should be the value of this integration? I told you psi square is the electron finding probability in 3-dimensional region. This is the small 3D region, and if you do integrate lower limit minus infinity, upper limit plus infinity, then the total probability of finding of electron, that is 1. Total electron is 1 fraction. It should come 1. By using this concept, if a wave function is not normalized, by taking normalization constant n, you can do normalization and you will get normalized wave function. But my purpose is not this complete wave function. My purpose, take only the radial wave function. Radial wave function. Now, the radial probability R square. Now, what is the radial probability of this small volume region? By taking a spherical, of course spherical, here I am only taking the radial coordinate, r square dv. That is the radial distribution function. Radial probability in a small sheath. Now you got what is dv. What is the volume of this sheath? Only by considering radial coordinate. If I do consider the spherical path, then you will get only radial coordinate. And dv 4 pi r square, 4 pi r square. This is wave function r square dr. Actually, this is the expression of radial distribution function, which is better, which will give better distribution of electron cloud in the radial distribution function versus radius plot. This is the important part of atomic structure. Now I will do plot this radial distribution function versus radius of different subcell of orbital. One thing remember, since when we have plotted radial wave function versus radius or radial probability versus radius of different subcell or orbital, there you got S at the origin is maximum. Radial distribution function versus radius, as well as radial probability versus radius, there you got at the origin S orbital at origin maximum. Other orbitals or subcell P, D, F, they are 0 at the origin. But here, when you will do plot radial distribution function versus radius, only will get 0 at the origin. How, sir? See, Although for S only, you know, at the origin it is maximum for S. But you know, when R is 0, due to this R is put 0, although it is maximum, total you will get 0 radial distribution function. That means S, P, D, F all have equal nature of qualitative plot. When you will do plot, radial distribution function versus radius, all are 0 at the origin. That is different from previous plots. Another thing you have to remember, you know, when I have plotted in this class in the first part, radial probability versus radius, there you saw that the amplitude decreases with increase of R. But here you will see the amplitude of the square plot increases due to increase of R due to this R square. Although it will decreases, but due to R increase, the total increases. That is like, it is like an intensive, but you are making it is extensive by taking the total volume. Since the total volume of the sheath increases due to high value of R, radial distribution function also increases. Remember this expression, then you will get correct idea about the different subcells or orbitals plot radial distribution function versus radius. Now I will take the example. There I will do plot. Of course, remember, there you have to count before doing plot the number of radial nodes. See my plot. Radial distribution function versus a radius. 1s, 2p, 3d, 4f, all I have taken parallelly, since you know number of radial nodes all have 0. That means all will give same nature of plot, radial distribution function versus radius. And you know, I told you many times, all are 0 at the origin when you are taking radial distribution function due to that small r, 4 pi r squared dr. Due to this r all are at 0. Now I am taking, this is radial distribution function of this nature, qualitative nature of plot are all same. I am not trying the quantitative, qualitative. That plot is important. Our syllabus is qualitative majorly. This is radius. I told you, no node at origin 0. What nature of plot you will get? This is the nature of plot. Done. Since no node, see no nodes. Now I take the next example. I am going to take next example. 2s, 3p, 4d, 5f. You can write 6e also. 6e is not required. Here all have number of radial nodes if you do calculate 1. And see the magic, how I will draw the plot, where it is the different from the previous plot. RDF, sorry, it is RDF. Here is one node. I told you all are at 0 at the origin. See, this is the node and I have increased the amplitude. See that I have increased the amplitude. Why amplitude increases? Since R increases. That's why amplitude increases. This is different. Previous radial probability, the plot was amplitude decreases. And one thing remember, The maxima, these are the maxima. Number of maxima equals to the number of nodes plus 1. Remember, equals to the number of nodes plus 1. Now the last example is enough for your concept. I think your concept is clear now. If I take 3s, 4p, 5d, 6f, all have radial nodes too. To count, all have radial nodes too. All are 0 at the origin. Now I will do plot. Very simple. Never it is difficult. Just to try to do the concept, clear concept. You have clear idea, result will automatically come. See, here two nodes I will take, and amplitude increases. Amplitude increases. Amplitude increases. See my plots. Very simple. These two are the nodes. Actually, this is manipulated plot and qualitative plot. Nature of plot all have said. Here, you know this radial part I am taking, not I am taking the theta phi containing part. Amplitude increases. Number of radial node you got, these two are the radial node. Amplitude increases due to this r square. I think you got idea. All three different plots that you have in syllabus. Radial wave function versus radius, that idea you got. There is different from PDF. Radial probability versus radius, that idea also you got. And today, the last part of my plot, atomic structure, this part is important. Radial distribution function versus radius, it is slightly different from others. Here S, P, D, F, all will show the same nature of plot if number of nodes are same. Also, I have discussed in the first part of the video nature of wave function, how you will be able to predict with respect to the variable r. And remember, these three different plots is important with respect to our syllabus. In atomic structure part, so many wings you will get in this part, in this chapter. It's a big chapter, fundamental chapter, majorly quantum mechanics, electronic configuration we have. From there we have dipole moment idea. Of course, we have idea about the stability of different configuration, ground state electronic configuration, degree of degeneracy. So many parts we have in the atomic structure chapter. We'll discuss different part of this chapter in different video. I have a plan to discuss about the stability. I'll make a video just to explain how we'll predict the ground state electronic configuration and degree of degeneracy. The degree of degeneracy part is more important part. And how Hund's multiplicity rule established, that I will discuss in different video. Degree of degeneracy term, you know, that is the same energy room of electron, that is orbital. If I take 2p, that is 3-fold degenerate, d subcell 5-fold degenerate, f subcell 7-fold degenerate, and you know s, p, d, f, their energies are different of a particular n due to repulsive interactions. But when the system is one electron system, in a particular cell, all subcells, all orbitals have equivalent energy. Now dear students, stay with us. You will get most important videos with respect to your syllabus, with respect to JEE-ADVANCED, JEE-MAINS as well as NEET. That part I will discuss in different videos. Stay with us.